Yo, what's up, everyone? Um, week 7, problem set 1. Time is flying by, um, and we have 2 weeks now until Christmas break, which is tight. And we're also going to finish our probability unit in the next 2 weeks. So I'm going to announce this to everyone, but my plan for the next 2 weeks is we're going to finish content this week. So we have 2 more lessons of the unit. This conditional probability, and then we're going to talk about tree diagrams for problem set 2. But then we're done with the unit and we have a week to review. And for this review, I'm going to try something new and we're going to do a live session, the second one. So I have to exactly figure out what I'm going to do, but I still think the videos are really good, and it's kind of just like, if you're not watching the videos, you don't learn. But if you are watching, you're going to learn. But I want to check in with everyone because I just feel like time is going by really quickly. And it's probably good to do some live sessions just to talk to everyone, because I guess my hope was more people would sign up for office hours. That's kind of just like maybe what's been disappointing me. Like, I'm not that disappointed that a lot of people are just copying this stuff, because that's not, surprising or even new to this year. But I was hoping a lot of students would kind of sign up for office hours, keep me in the loop of their life, ask me questions about stuff. And, I get like 4 to 5 people a week, and that's good. But obviously, I want to talk to everyone. So I'm going to go live. I'm going to give a review video on Monday next week, but then I'll go live Wednesday or Thursday. So whenever you have normal, like the scheduled time for class, statistics at second, third, and fourth period, I will go live. And we won't just do review. I'm going to talk about other stuff as well. So I think that'll be pretty fun. Before that, though, let's finish the unit the way that we've been doing, which is learning through videos. And I think we have a great lesson. I'll read it, and I didn't give you the Venn diagram, just copy it down. And we're really focusing on notation. Okay, we're going to talk about the last probability notation you could see, which is very satisfying because there's only like 4 different weird symbols and stuff. And we're going to talk about the last one today. So first, though, it says, you are interviewing male students at San Jose State. Ask them whether or not they have tattoos and or piercings. The following Venn diagram shows how students responded. And then they're naming the events. Event A is a student has piercings, and event B is a student has tattoos. And then there's a big intersection and a significant portion who have neither. And then we're going to be asked to solve questions. So I didn't make you do the word problem and actually do this for this one. I gave it to you. But we want to talk about just some probabilities. And we'll start, though, with something that we've done before. What A says literally is find P, B, upper letter C. And if you see a C or anything above the letter, like this means the complement. And that means that the probability that B doesn't occur, right? So if it just said probability of B, that would be the probability that a student has tattoos, right? So in this case, 30 of the students have tattoos because it's the intersection plus those 5. So the probability of B is 30 out of 200, right? You add them all up and there's 200 students. And if you want to find the complement, you could do this first, right? But if we saw a probability of BC, that stands for the complement, and that's everyone else, right? That's every student that doesn't have a tattoo. And if we have a Venn diagram of 2 events, there's only 4 spots, right? So it's not tattoos. So it's going to be the pierced students who didn't have tattoos, and then the neither, right? So these 2 always add up to 100%, right? You either are B or you're not B. So if you ever see this, it just means not that event. And that's going to be like 85%. Gotta find my calc. So yeah, that's just our warm up. The rest of this is the new stuff. And it's actually very easy, at least to start. For B, it says, if a student has piercings, what is the probability that they also have tattoos? Okay. And the gist here is that anytime we're asking for a probability and it doesn't give us like a condition, it's going to be out of the total, right? The probability of the component B is out of 200 students, right? Because we're talking about all of the students and how many of them are not or don't have tattoos. But if we see this, if a student has piercings, what is the probability that they also have tattoos? The bottom of my fraction isn't going to be 200, right? It's going to be just the students who have piercings. And this is what conditional probability is, right? We're trying to find this probability if we know this is true, okay? So to do this, we're gonna have to be intentional with both parts of my fraction, okay? And I'm gonna write the bottom first. 40 students have piercings, right? So out of those 40 students, how many also have tattoos? So all you have to think is that if it says something like this, and the phrasing we're gonna start using is like the word given, it's not the whole Venn diagram. It's just the given portion. Of those 40 students, 25 also have tattoos. So it's 25 out of 40, right? We know that not that many students, only 15% of students have tattoos. But if a student has a piercing, I was gonna say edgy, that's not the right word. They're like aesthetic, that's a better word. I think they're both really cool. I'm considering, I guess, I don't know. I'm old, I don't know, but not that old. But yeah, if a student has piercings, they're much more likely. In this case, there's a 62% chance that they have tattoos, okay? So hopefully that makes sense to everyone. And that's the logic if we ever see the phrase given. So now we're gonna read it in a way that's more common. It says, what is the probability that a student has piercings given that they have tattoos? And all given means is that whatever the given information is, right? And this is a good way to solve all math problems. Figure out what's given. And it's told to us that the student has tattoos. Okay, so if you see given, that means that is true. And we're trying to find how likely is this to be true, assuming or given that this is true. So this shouldn't be too difficult, right? 30 students have tattoos. And of those 30 students, 25 have piercings as well. Okay, so if you see given, the given information is going to dictate the bottom of the fraction. Okay, and it's going to tell you your total, right? We're not talking about all the students. We throw away like all the other students that don't have tattoos, and we're just trying to figure out the probability of having piercings if you're one of those students. So far, I think pretty straightforward. And like a lot of this unit, really the only thing that's going to be hard is we're going to now talk about it with the notation. Okay, so it's almost dumb, but so D says find P A line B. Okay, and that line in probability indicates given. Okay, so if you see this, like for me, I'm just going to try to always read things out loud or think about them without confusing myself too much. So this means what's the probability of A given B? And in this case, now we just have to think what's A and what's B. And it's going to be one of the two above us. That's the hint for this one. A in our case is that a student has piercings. B is that a student has tattoos. So all this is saying, if you see the PA line B, is what's the probability of A given B? And then I'm going to put that in real words. What's the probability a student has piercings given tattoos, which is what we just did. Okay? So for the rest of this, we're going to just deal with the notation itself. But I'm going to always kind of write the whole thing out. And I think it's really clear this way, right? So it's going to be 25 out of 30. The hardest part is going to be that sometimes, or like knowing what's given and what's not given. Okay, and that's why I'm going to write it out. Because if it had said probability B line A, we could solve that as well. That's the probability that you have tattoos given that you have piercings, AKA what we said in B. Okay, so while I don't personally think this is challenging, the most challenging part is going to be to know exactly what is given and what's not given. So that's why I like to write it out. All right, that's number one. I think that's pretty good. And here we're going to go back to a two-way table. This is like the most common graphical display if we're going to do probability. And we know that we can take a two-way table and make a bunch of different Venn diagrams just depending on what we're talking about, right? But a two-way table is going to give you a whole lot of information. This one is talking about the preferred superpower of students. I took all of these from the book. I thought they were kind of good questions, honestly. So like we have a bunch of students in different ages, and then they were asked kind of what they want their superpower to be. What's the most important thing from the word problem though, is it describes our events. A equals elementary school students, and I could even put that there. That's A. B is that a student is in high school. C is that a student wants to fly, don't we all? And then D is that a student wants to be invisible, and we all definitely want that, at least sometimes. This question is really technical, and that's why I think we'll go through it quickly. These are all the things other than complement they could be asked, but we want to start first with a bunch of given scenarios so that we can practice this. First, it says find the probability of D given B. So invisible given they're in high school. So we got to be clear what that means in the context of a two-way table, right? So we're not talking about the total students. It's saying given that a student's in high school, so one of the 50 students in high school, what's the probability that they want to be invisible? Okay, so the given, the second part of it, the second letter is always going to tell you your total. Okay, and I think that that's also kind of clear and cool. Given that the students in high school, so one of our 50 students in high school, 25 out of those 50 students want to be invisible. So that's 0.5. We'll roll through the rest of them very similarly. The point of B is that the two letters we have can give you different probabilities depending on what's given, right? So high school given invisible is going to have a different bottom of the fraction, right? So invisible had 50 students again, so I guess that's kind of annoying. But it's these 50 students, all right? We're talking about the 50 students who wanted to be invisible. One of those students, how likely are they to be in high school? And that's annoying. It's going to be the exact same probability, but hopefully you see why it's this divided by this and not this divided by this, right? So if it was like the probability of elementary school, given they want to be invisible, it'd be 5 out of 50. The second letter is going to tell you the bottom of the fraction. The first letter is going to tell you the kind of the top of the fraction. So 50% of the students who want to be invisible are high school students, and 50% of the high school students want to be invisible. For C, the probability that they're in elementary school, given they want to be invisible. So actually, I just said that out loud. So of the 50 students that want to be invisible, 5 of them are in elementary school. And the idea of that is like everyone is more confident than. You don't necessarily like want to be invisible at that point versus like wanting to be, you know, a boss and go fly. But yeah. The last one I'm doing is intentionally weird. It says find the probability of A given B. And remember, one of the weirdest parts of a two-way table, or the only kind of weird part, is sometimes you could be asked to compare things that are along the same variable. So this says elementary school given high school. And that's like pretty nonsensical, right? Once we write it out, that doesn't really make sense. What's the probability someone is in elementary school given that they're in high school? So you could try, right? There's 50 students in high school, but we're talking about their superpower, right? In the second row. There's no way that you could be an elementary school student if you're also a high school student. So it's just going to be 0. So just be careful about stuff like that. But I think the method of writing it like this is like going to be super effective. The last two I just review. I just want you to get comfortable. And I messed up. It should say probability, like a P in front of it. And I put it on your worksheet already. But we got to get comfortable seeing all the things at once. So we know that the hill stands for and the U stands for union or. So if I'm going to use the strategy of writing out literally what it's asking, this is saying the probability of an elementary school student and a student that wants to fly, right? Elementary school student and fly. Very easy on a two-way table because we have our elementary school students, these 50 students, but of those 50 students, 20 want to fly. So it's going to be 20 out of what? That could be the hardest part. If it doesn't ever say anything's given, you're talking about all the students, okay? And that's really important. 20 of the students are in elementary school and want to fly out of all the students surveyed, okay? So it's gonna be 20 over 150. You'll only really see a change in the bottom number if you're given something. And then finally, B or D. And let's write it out first. This is high school or invisible. And we have a formula for this. I'm giving you like a formula sheet at the end. But remember that the complication is it's high school or invisible. So it's these high school students, these 50 high school students, and these 50 students that want to be invisible. But if you just did 50 plus 50, you would double count the intersection, right? So the formula for this, like, and hopefully you understand, this is this plus this plus this plus this plus this plus this. So it's going to be 50, 60, 75. But if you wanted to write it out, you could take the totals. So the probability of students in high school plus the probability that someone wants to be invisible minus the probability of both. You have to always get rid of the intersection when it's an or statement, right? So it'd be 50 plus 50 minus 25 or 75 out of 150. And again, I messed up. I shouldn't have 50% of the answer for like all of these. Hopefully that makes sense to everyone. You could have done in your head, but if you want the general additional formula, which tells you what you can do in a union situation, you can always add up the totals for these probabilities, but you have to subtract away the intersection. All right, excellent. We have one final part of this, and I'm really excited about it. We're talking about independence again, which we're going to cover more tomorrow to finish the lesson. So we're going to come full circle because we talked about this a lot to start the lesson or the unit. But we're going to talk about it now in the scope of Venn diagrams. And I think it's pretty fascinating. 3 and 4 are like the same question, but the numbers are changed so we can understand it. For 3, it just says in an interview of 80 students, he asked how many use Instagram and how many use Facebook. And he finds that 20 use Facebook, 60 use Instagram, and 18 use both. A equals Facebook, B equals Instagram. And I want to draw a Venn diagram. This question was from the textbook, which made me really proud. Like the textbook that I use had the word Instagram in it. So here are 2 things, FB and Insta. This one it's asking you to draw it, but it hopefully isn't too bad. This is really standard for us. We know we want to start in the middle and then work to the 2 sides. So 20 people use Facebook, but 18 of them use both. So there's only 2 people who are on Facebook that aren't on Instagram in my survey, but then there's 42 people who are on Instagram, but not Facebook on this, right? 20, 60, and then we have to add up to see what's left over. So 62, there's going to be 18 students who are not on either of the platforms. So that's how we draw it. And we're going to start with just finding some probabilities. And then there's a reason why we're finding these particular ones. First, it says find the probability of A given B. So FB given Insta. So the given tells you what the bottom of the fraction is. This is saying how likely is someone to use Facebook if they use Instagram. So there's 60 students who use Instagram, and 18 of them are on Facebook as well. So 30% of the Instagram users also use Facebook. So that's that probability. 30% of this circle is in the middle, right? 18 out of the total 60. For C, and this is a new phrasing, it says find the probability of A given not B, right? So what that means is what's the probability that they use Facebook given that they don't use Instagram? The C stands for complement. So if we knew that 60 students used Instagram, the bottom of my fraction is going to be the other 20 students, right? We want to find out how likely are you to use Facebook if you don't use Instagram, right? So 20 students, this and this, these are the only students who don't have Instagram. Remember, in a Venn diagram, there's 4 numbers. These 2 numbers are Instagram. These 2 numbers are not Instagram. So 20 don't use Instagram. And of those 20, 2 of them use Facebook, right? So that's 10%. Good. So hopefully that makes sense. If you're an Instagram user, there's a 30% chance that you use Facebook. If you're not an Instagram user, there's a 10% chance that you use Facebook. And then what's the probability that you use Facebook in general? So maybe I could have even led with this, but 20 out of my 80 students use Facebook. The bottom of the fraction is going to be total unless you have given information. Good. So for E, and this is our thinker, it just says, is using Facebook independent of using Instagram? And this is something that you could think about without doing math, right? And what this means is that, first, what independence means. So again, from really early in the probability unit, independence means that it doesn't matter if you use Instagram or not, you're going to use Facebook at the same rate, right? So an Instagram user and a non-Instagram user would both use Facebook at the same percentage, right? But what we're seeing from above is that using Instagram is an indicator of how likely you are to use Facebook, right? The Instagram users are way more likely to use Facebook. And if you don't use Instagram, you're probably just off social media in general. So if it's saying, is using Facebook independent of using Instagram? The answer has to be no. And the reason is these probabilities are different, okay? If you use Instagram, you have a higher chance of using Facebook than if you don't use Instagram. So if you're reading the phrasing here, Facebook was the beginning of our phrasing, but Instagram, we were testing if you use Instagram versus whether you don't use Instagram. Is there a difference between the two? And that's always how you're going to solve independence from now on. And if that was a little confusing, we'll now do an example with independence so that it all makes sense. And I like using dual examples that just have different numbers so that we can see. I'm going to fill this in really quickly. The only number that changed was 15 is in the middle now. Good. So this one doesn't guide you. It just says, is using Facebook independent of using Instagram? And the formula, so first let me just show you this because we're at the end. I'm giving you this formula sheet and a lot of these are given to you on the AP exam. We'll talk about that, near the end of the year. Don't let it intimidate you, but we've just been going through these probabilities throughout the unit. But if you ever want to find independent events, you need to figure out if using something versus not using something affects the variable in question. Okay, so if we wanted to find this, all we should do is find the probability of A given B versus the probability of A given not B, right? If these probabilities are the same, that means it doesn't matter if you're on Instagram or not. You're going to use Facebook at the same rate, and therefore it's independent. So in the first one, the probability that you use Facebook if you use Instagram is 15 out of 60, right? And that's 25%. 25% of the Instagram users also use Facebook. Here, of the 20 students who don't use Instagram, what percent of them use Facebook? And that's this 5, right? So the first one, and I think that that's actually really easy. If you want to find the independence, you start with the circle, 15 out of 60. And then the second one is the 5 out of 20, right? 20 students don't use Instagram at all, but 5 of them still use Facebook. So obviously, like, they're going to be the same based on like the lesson and everything. But what that means is that in this case, it doesn't matter if you use Instagram or not. There's a 25% chance that you use Facebook, right? It's unaffected. The probabilities are the same. And one final thing that you could compare to, right? This is the best way to do it. But what we were doing before without even really talking about it was we were always comparing this to just the probability of A. So now let's just think, how likely are you to use Facebook in general, right? 20 out of my 80 total students use Facebook. And that's also 25%. So independence is usually really obvious because all your percents are going to be the exact same, right? 25% of my students use Facebook, which is the same as the first question. But if you break that down into your two components, they're equal in this case and not unequal, right? And I think, you know, I love this and I think it's really cool. Hopefully that makes sense. 25% of my people use Facebook. And if you split that up into Instagram users and not Instagram users, the probability stays the same. So that's how we know that it is independent. Alrighty, I think that was a great lesson. Hopefully you guys enjoyed it. One more lesson before the unit is over.